Hey Ninja Warriors, welcome to yet another power-packed session for JEE Advanced. So this is the part 2. We have successfully finished part 1. So what we are doing right now is the topics which are not there in JEE Main but are there in JEE Advanced, right? So we'll finish it off today only, and before I start any further, you guys have to let me know whether I'm perfectly audible and visible, so that without any further ado, we will start this session, because this session has got delayed a lot of times, right? Okay. All right. I can see Praveen. Okay. I can see Ashwant. All right. Okay. Keep joining, keep liking the session, and we are good to go, I guess. Okay. So let us begin with this particular session over here. Okay. All right. Yeah. So before I start any further, I have to let you know about the VEDANTU which is happening at 1st May 12 p.m. The link of this event is given in the description box, and you are going to enjoy this particular event a lot. So stay tuned and book the slot of 12 p.m. Okay. So let's start now. But before that, very important announcement, especially for those people who are very, very serious about JEE Advanced preparation. These books, JEE Advanced Rank Accelerator Physics, Chemistry, Maths, absolutely amazing and on point book for your JEE Advanced preparation. Link is given in the description box. And by the way, this book is having PYQs of JEE Advanced. Along with that, this book is having pattern wise question like matrix match, assertion reason, multi-select question, paragraph type questions, which are very, very useful for your JEE Advanced examination. Yes. Okay, tomorrow I'm gonna take UGEE most important 50 questions, है ना? Session is already scheduled. Good afternoon. So without any further ado, let's start from where we have left. So in previous session, we have started with complex number. So triangle inequality was a topic which was there in JEE Advanced but was not there in JEE Main. So we did that. Apart from that, we did some very important properties of binomial theorem. Post that, we started with probability, and we touched all the topics like Bernoulli's trials and binomial probability distribution, along with some topics which are like intersection of probability and statistics, right? So we ended at the probability. Now we are picking up from probability and statistics. One topic was left, and post that we will start with vector and 3D geometry and calculus. Okay, so vector and 3D geometry is today's topic. The main topic is vector 3D and calculus. Okay, so we'll finish it off in 10 minutes. The last remaining topic, mean and variance, expected and random variable, and then we will jump on to vector and 3D geometry. Okay, are we ready? Okay, so mean and variance, let me just give a quick recap of mean and variance. So over here, you can clearly see that mean is denoted by either mu or x bar. Okay, so probability distribution is what I have already covered in the previous lecture, but in case you have forgotten, I will revise you as well, right? And random variable. Okay, all right. So yes, now mean. What is mean? So mean is, we know that sum of all the observations upon total number of observations, right? But when frequency is involved, that means the data is discrete. When discrete data is there, then f1 x1, f2 x2, f3 x3, basically sigma fi xi upon sigma fi, where f is the frequency, x is the observation. Okay, all right. Yes, clear? Yeah, this is advanced topics only. We are studying JEE Advanced topic only, right? Now mean and mean for now. For random variable, mean is different, variance is slightly different. Okay, the idea is the same, but the formula gets a little bit different. Okay, so over here, if I talk about mean, so mean is nothing but sigma pi xi upon pi, just like sigma fi xi upon sigma fi. Like that only, sigma pi xi upon pi, but sigma pi is nothing but 1. You know that sum of all probabilities is equals to 1. Right? So this is going to be 1. This is equals to sigma pi xi. Okay. So what is the formula for mean for a random variable? Write down in the chat box. Sigma pi xi. This is the formula. Okay. And it is also known as the expectation. Previous years like 2023, 2022, this topic was there in JEE main as well. Okay. And now what about variance? So this is your mean, this is variance. We'll solve problems so to get clear picture. Variance. Now variance for the normal statistics chapter, let us recall. So suppose you are having n observations. So we are actually having two formula for variance. So deviation, basically what, so variance is nothing but deviation from mean, the squared quantity upon n. Right, so x1 minus x bar upon ka whole square upon n plus x2 minus x bar whole square upon n. This is your what? Variance, right? Okay, this is the formula for variance. And one more formula, one very popular formula, mean of squares minus square of means. Mean of square means, that means you have observation x1 square, x2 square, x3 square, and you are calculating mean. How do you do that? You just add x1 square, x2 square, x3 square all the way up to xn square and divide by number of observations. What about this? Sigma xi square upon n. So you calculate mean and actually you square it. So square of a mean, right? So this is your revision of statistics, nothing else. Okay. This is revision of statistics. Now for random variable, again there is a slight difference, just like your mean. So this is your mean formula for random variable, right? This is also known as expectation. We write it as E of x, expectation of the random variable, right? Now one formula is xi minus mu whole square into pi. Now mu is what? Mean. Xi is the observation and this is your probability. Pi is the probability, right? Just like your sigma square, the original formula, the statistics formula was xi minus x bar ka whole square upon n, and we have sigma as well. You can see it clearly, x bar is mu only. So you can clearly see that this is nothing but multiplication with pi is this thing which is different, and upon sigma pi will become 1, just like that. So this is anyway 1, right? Another formula you can see on your screen is this, right? So another formula is this, which is sigma square, sigma pi xi square minus mu square, right? So this actually is nothing but E of x square, expectation of x square. This is nothing but E of x, that is mean whole square, and this is your variance. This is the formula for your variance. Please note it down. Okay, all right. We'll solve question, then you will be able to understand. Okay, all right. Now an unbiased coin. So this was there in JEE in 2020 where this topic was included, right? An unbiased coin is tossed 5 times. Suppose that a variable x is assigned the value k when k consecutive heads are obtained for 3, 4 and 5. Otherwise x stays value minus 5, then the expected value of x is. So what they are asking is E of x. That's what I have understood. I have not understood the whole question. So we need to actually read it one more time for better clarity, one by one, slowly. Let us do that. Yes, unbiased coin is tossed 5 times. So over here n is coming out as 5. So basically same thing, same experiment is getting performed 5 times. Okay, so now gradually it is getting clear. Now x is, we know x is random variable and x is nothing but k, and the value of x is clearly 3, 4, 5, right? And this is nothing but consecutive heads. Okay, otherwise x takes value minus 1, then the expected value of x. So expected value of x is what? Sigma pi xi. So for that we need to draw probability distribution table. That's it, and your job is done. Once you are done with probability distribution table, then you will be able to calculate this, right? Let me just show you how to make probability distribution table. Let us do that. Let us start solving. So first of all, k is equals to 3. That means 5 times if I toss the coin head, tail, I will get exactly 3 consecutive heads, right? So when can it happen? So basically first 3 will be head, and then I have to plant a T and then a head. So can you clearly see 3 consecutive heads are there? Or what we can do is we can position these 3 head starting from the second position. So H1, H2, H3, H4. So H, H, H. And now here I have to plant T. I have to plant T. Why? Because if I plant it H over here, it will become 4 consecutive head. Please understand that I have to make exactly 3 consecutive head. So I have just placed 3 heads over here in the first position and 3 heads in the middle position, and now 3 heads again in the first position, but this TH will become TT. This is also a case. And also one more thing, now that the last 3 position will be triple H, and now this T will be replaced by H, so that H, T, H, 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 so that last 3 will be still H. Okay. These are the possible options of getting 3 consecutive heads. Okay. All right. So for that, let us calculate the probability. So unbiased coin is tossed 5 times. What is the total outcomes? 2 raised to power 5. That is 32. Right? So 5 favorable outcomes you can clearly see. That's why 5 upon 32. Right? Now you got the drill. Now you got the drill. I guess now you understand that how to calculate probability related to k is equals to 3. Now can you calculate probability related to k is equals to 4? That means we need exactly 4 consecutive heads. This is actually very, very easy. Only first 4 head and then a tail, then last 4 head and first will be a tail. So 2 by 32, that means 1 by 16. Okay. All right. Now k is equals to 5. That is very easy. We are doing 5 times and we need 5 consecutive heads. Oh my God, 1 by 32. Absolutely easy. Okay, now let us try to make the probability distribution table. So when your x random variable is 3, what is your probability? 5 upon 32. When your random variable is 4, what is your probability? 2 upon 32. And when it is 5, what is your probability? 1 upon 32. And. When otherwise means what? Otherwise, your value of x is -1, right? And your probability is what you have to figure it out. Okay, all right. So otherwise, actually, so this is your main event, 1, 2, 3. This is your remaining probability. So this probability will be 1 minus 5 by 32 plus 2 by 32 plus 1 by 32. Yes, 5, 6, 7, 8. So 1 minus 8 by 32. So 1 minus 1 by 4 will be 3 by 4. All right. So that's how you are supposed to do. And now what you are here to calculate? Expectation. That means sigma pi xi. That means 3 into 5 by 32, 4 into 2 by 32, 5 into 1 by 32, minus 1 into 3 by 4, or you can say that it can be, so 12 by 32, right? Yes. So we have to calculate the remaining probability, and the remaining probability is 24 by 32, or you can say it is 3 by 4. Okay. All right. And now what is your expectation? Sigma pi xi. So you just have to multiply. So expectation would be minus 1 into 24 by 32 or 3 by 4. One and same thing. Right. So minus 1 into this, and then 3 into 5 by 32. 4 into 2 by 32. This is the formula, my dear students. And finally, you are getting 1 by 8 as the final answer. Okay. All right. Okay. Clear. So this is JEE main based question to clear your doubts, or to clear the concept, because now you will say ki, okay ma'am, this is JEE advanced session, why are you taking JEE main problem? So the thing is, see, you have not studied this particular concept, right? So what I have to do, I have to teach the concept and do a JEE main level question, and then we will definitely do JEE advanced question. Let's clear the concept. If I do JEE advanced question, then you won't be able to understand that, okay? Especially for this topic, है ना? all right? Because this is something which is absolutely new for you. All right. Now one more thing, okay? For a probability distribution, your mean, another formula for mean is n into p. N is nothing but number of trials and p is nothing but probability of success, okay? And what about variance? Variance is nothing but, yes, Q is probability of failure. So variance over here is nothing but NPQ, where P plus Q, mind it, P plus Q is equals to 1. This is your variance, okay? And what about standard deviation? That is going to be square root of NPQ. These are the two more formulas which are very important, and it was actually there. अनविजय सिंह, वही तो अवनिजय सिंह, वही तो जेई मेन का लेवल था ही. अरे it was a problem for JEE main only. I have written that also. It is from JEE main. Why? Because I have taught you some concept and directly I can just not throw a JEE advanced question. I have to make you understand the concept so that you will be able to solve a JEE advanced question. Okay? Please trust this. Okay? Trust the process. Okay? All right? Yes, NPQ. All right, all right, all right. Now, and again, JEE main problem to understand this NP and NPQ problems. A bag contains 30 white and 10 red balls. Okay, 16 balls are drawn one by one randomly from the bag with replacement. If X be the number of white balls drawn, then mean of X upon standard deviation of X is equals to. So mean of X is NP. Upon standard deviation is NPQ. That's what we are looking for. Okay. All right. So 16 balls are drawn one by one. So same event is happening. How many times? 16 times. So first thing is your N is coming out as 16. All right. Now P is probability of success. Q is probability of failure. To know the value of P, we have to define what is success and what is failure. Then we'll be able to understand what is the P and what is the Q. Okay, so first, yes, so number of white balls drawn. Okay, so number of white balls drawn is nothing but probability of success. Okay, all right. So over here, yes. So first of all, probability of success will be number of white balls. So 30 upon 40 is the probability of getting a white ball. That is P, probability of success. What would be the probability of failure? Getting a red ball is failure. So that would be 1 by 4. So Q is nothing but 1 by 4. Now the question is absolutely easy. What you need, and N is 16, I have already told you. Now what they are asking is mean upon standard deviation. So mean is N into P. So 16 into 3 by 4, that is 12. 16 into 3 by 4. So 16 into 3 by 4 is nothing but your mean, that is 12. What about variance? NPQ. So this is going to be 3. How come? So 16 into 3 by 4 into 1 by 4. So 3. Okay. All right, so 12 upon root 3 is the final answer, and if you rationalize it, you are going to get 4 root 3, which is option D, again from JEE main. Okay, clear? Perfect. Now let us start with vectors, which is the main and very important topic of today's session, vector and 3D geometry, because there are so many topics which were deleted in JEE mains but are there in JEE Advanced. For example, scalar triple product, vector triple product, their properties, their applications. Okay, this is from vectors, and from 3D geometry, the whole complete planes and the interaction between line and plane, family of plane, the whole thing related to plane is deleted. So we have to tackle that as well, right? So are we ready for vector and 3D geometry? Shall we start? So first of all, scalar triple product. Let us understand what is scalar triple product. So over here, if we take 3 products, triple means 3. So 3 vectors will be involved. Then scalar triple product, or you can say box product. Yes. So we call scalar triple product as box product as well. And it is defined as dot product between A and B cross C. So basically what you are going to do is you're going to take cross product of two vectors and take dot with the third vector. Okay. So A dot B cross C. This is your scalar triple product. Now who is going to tell me that scalar triple product is a scalar quantity or a vector quantity? This thing is a scalar quantity or vector quantity. So how do you understand, is this scalar or vector? First of all, B cross C. है ना? Let's understand in segments, in the portions. So B cross C, ma'am, is a vector quantity and A vector is also a vector quantity. Performing a dot product between two vectors is a scalar quantity. So ma'am, this is actually a scalar quantity. Yes, this is a scalar quantity. That's why we call it as a scalar triple product. Now you know that why we name it as a scalar triple product. Okay. So it is denoted by this, the bracket and the three vectors. So this is nothing but A dot B cross C, or we call it as box ABC. Box ABC. Okay. I hope that this is clear. All right. Now, there are other scalar product as well. Now, you must be wondering, ma'am, okay, A dot B cross C, is it mandatory to just make a cross product between the last two vectors and take the dot with first vector? Is it mandatory? No, no, no. So, this is also a scalar triple product, B dot C cross A, C dot A cross B. And the question arises, ma'am, whether these three things are equal or non-equal. Are these things same? So we will understand this, but first of all, let us understand what is actually a scalar triple product. So taking a dot product with cross product of two vectors. Okay. Now whether they are equal or unequal, we will understand it. Okay. All right. Yes. So this we have already studied. Scalar triple product always result in a scalar quantity. Okay. All right. Yes. Now let us understand the geometrical meaning of scalar triple product. For that, we have to understand parallelepiped. Now you must be wondering, ma'am, kya? What? Parallelepiped. What is parallelepiped? Let us understand the structure first. It is a 3D figure. It is a 3D object, and which is formed as, so it is not a cuboid. Let us understand. It is not a cuboid. In fact, cuboid is this. Cuboid is this. Right? This is your cuboid. Right? This is your cuboid. So cuboid is formed by joining the rectangular faces. But this parallelepiped is formed by joining the parallelogram. Yes. So what we have to do is we have to just push this cuboid so that this is 90 degree, but we don't want it 90 degree. We want it to become a slightly changed to that 90 degree. So this is your parallelepiped. Can you see? That means that your faces are nothing but parallelograms. Okay. So now you understand how a parallelepiped is made. Clear? Okay. Now for a parallelepiped, we need to have three coterminous edges. This is the term which you will see in your क्या बोलते हैं, JEE Advanced paper. This is the term that you will see in JEE Advanced paper. And by the way, this actually is very, very important. Parallelepiped. This is very important for JEE Advanced. There are questions from tetrahedron and parallelepiped as well, right? So can you see now that we have A vector, then we have B vector, and then we have C vector. So these three are originating from same point. So that's why A, B, C are called as coterminous edges. What do we call it? Coterminous edges. Okay. All right. Clear? Now volume of this particular, now you must be wondering, ma'am, what? What are you doing? You were teaching us scalar triple product and now you are distracted and you have given us a parallelepiped. So basically, the geometrical interpretation of box ABC or scalar triple product is nothing but volume of parallelepiped. Yes, So volume of any parallelepiped is given by magnitude of, because volume is always positive, magnitude of A dot B cross C or magnitude of box ABC. This is the geometrical interpretation. जैसे for example, a cross product is A cross B. What is the geometrical interpretation of cross product? Who is going to tell me? What is the geometrical interpretation of the cross product? Who is going to tell me? It is a parallelogram. Area of parallelogram is given by magnitude of A cross B. So similarly, A dot B cross C, the geometrical application is, this is the volume of a parallelepiped. I hope you remember this. Okay, all right. Now formula for scalar triple product, how to calculate? Suppose you are given with 3 vectors, then how will you calculate the scalar triple product? So 3 vectors you can clearly see on your screen. They are already here. How to calculate? So box ABC is nothing but A1, A2, A3, B1, B2, B3, C1, C2, C3. That means just purely determinant you have to form, and the value of that determinant is gonna give you scalar triple product value. Now you must be wondering how? Ma'am, I was also thinking this is A dot B cross C. So I would have found out B cross C first and take a dot product with A vector. Actually, what you are saying is exactly same thing. Yes. So B cross C is what? Tell me. I, J, K. That's it. Same determinant, only B1, B2, B3 and C1, C2, C3. And now you are taking dot with A. So dot with A means what? Dot with A means what? That I cap will be replaced by A1. So this is going to be A1, A2, A3. Right? So same thing is gonna happen over here. Let us understand with the help of a question. A vector is given, B vector is given, C vector is also given. Represent 3 coterminous edges of a parallelepiped. Volume we have to figure out. So volume means what? That we have to figure out modulus of that determinant. Very easy question. So I'm not going to solve it. I'm going to show you the solution. So volume is magnitude of box of ABC. Okay. So magnitude of box of ABC. So A vector is 2 minus 3, 0. And then 1, 1 minus 1. Add 3 minus 1. So this is it. Okay. Alright. So this is your determinant. This determinant value will be equal to what? 4. So 4. If it is minus 4, we have to take mod. So 4 cubic units is going to be your correct answer, option B. Is that clear? Is this question clear? Yes. Shall we move forward? All right. Okay. Now there are 3 vectors A, B and C. These are the non-zero vectors, such that what they are saying is that magnitude of box ABC is nothing but magnitude of A, B and C. Then we have to figure out which of the following is true. Okay. So first of all, A cross B is what? Who is going to tell me? A cross B is AB sine theta n cap. Right? If I talk about magnitude of this, it is going to be n cap is gone. Okay? AB sine theta. Now what about, yes, so this is A cross B. Okay? Alright, so if I talk about A cross B dot C, and we have magnitude as well. So this is going to be magnitude of A cross B, magnitude of C, and we have cos phi, right? Here theta is the angle between A and B, and phi is the angle between A cross C, A cross B and C. A cross B and C. Right? Okay. Now A cross B, if I put it over here, what I'm gonna get is magnitude of A, magnitude of B, and magnitude of C was already there. Sine theta cos phi. But in the question, what they are giving is this is nothing but magnitude of A, magnitude of B, magnitude of C. What does that mean? That this sine theta is also 1, cos phi is also 1. Sine theta is 1 and cos phi is also 1. That means theta is 90 degree and phi is 0 degree. What does that mean? Theta 90 degree means what? A and B are perpendicular to each other. Definitely A and B are perpendicular to each other. That means A dot B is 0. A dot B is 0. A dot B is 0. Okay. Alright. A dot B is definitely 0. But what about this? What does phi 0 means? Phi 0 means that the angle between A cross B and C becomes 0. So let us understand this. Let us understand this. Let us understand the whole thing. So let me just tell you that this means that A, B, C are mutually perpendicular vectors. Wherever they say that A cross B dot C is ABC, that means sin theta 1 cos phi 0. Theta 90, phi 0. What does that mean? Tell me in the chat box. This means that A, B, C are mutually perpendicular vectors. Let me show you. Okay. So over here, let us open it. A cross B dot C is given as ABC, right? Let us expand this. So this is one vector, this is another vector. Dot product is magnitude of first vector, magnitude of second vector, cos theta. Where theta, you can, this time theta, you can just understand it is angle between A cross B and C. All right. Right. Theta is angle between A cross B and C. Now A, B, C sin theta cos phi. Where is this sin phi coming from? So A cross B, if I open, A, B sin phi. Right. So this is only gonna happen when sin phi is 1 and cos theta is 1. That means phi is pi by 2 and theta is 0. And this actually means that A and B, B and C are mutually perpendicular vectors. Now you must be wondering, ma'am, okay, what you are saying is this is pi by 2, this is very clear. But theta 0 Z is not actually very visually clear that why these angles are mutually perpendicular. So let me just show you. So imagine that these are the three coterminous edges. You can clearly see this is your A vector, B vector, C vector, right? Now theta is the angle between B and C, and phi is the angle between what? Phi is the angle between B cross C and A. Okay. So phi is the angles, right? Theta is the angle between what? B and C. Phi is the angle between what? A vector and B cross C. So what is B cross C? Let us define it. Now you have to visualize B cross C. So this is B and C is minus Z axis. So B cross C will be this. So this direction is nothing but B cross C. So B cross C and A vector, can you see this is your A vector, this is your B cross C, so the angle is phi. If you want to make phi 0, that means this A vector should get coincide with B cross C, right? So how will it look like? And obviously B and C should be perpendicular because theta is 90 degree, phi is 0 degree. So how will our diagram will look like? It will look like this. Can you see? This phi will become 90 and your A vector will get coincide with B cross C because this angle should be 0. So this is your 0 degree. Okay. Alright. So theta 90, phi 0. This is the visualization mutually perpendicular vectors. Okay. Alright. Yes. Now properties of scalar triple products. Let us understand the properties of scalar triple product. Okay. Okay. So I'll come back in 2 minutes. Is it fine? I'll sip some water and I'll come back. Okay. Okay, okay, I am back. I am back. Chalo. Properties of scalar triple product. Okay, come back, come back. ठीक है, चलो. So yes, in the beginning I already told you that A dot B cross C, B dot C cross A, B dot A cross C, are these equal or are these unequal? Let us understand. So basically the magic is position of dot and cross can be interchanged. Yes, so how we are going to interchange? A dot B cross C. So now this dot will become cross. So A cross B, can you see, and this cross will become dot. So A cross B will be together dot C. All right. Yes. So yes, this is the very first property. Dot and cross can be interchanged. Okay. So the value of scalar triple product remains unchanged if the same cyclic order is followed. Okay. So the idea behind this, idea is what? That A, B, C, the cyclic order should remain same. If cyclic order is intact, all the values of scalar triple product will be same. So over here A, B, C, you check cyclic order. Yes ma'am, same. A, B, C, yes ma'am, it is same. So that's why it is what? Same, right? So box A, B, C, right? Now again B, C, A. So B, C, A is also actually same. How come? Because can you see cyclic order is same. A and then B and then C. A, B, C. The order should not be changed. I will tell you how, actually what it looks like to get the order change, okay? And C, A, B again same thing, A, B and C. So here the order is not getting changed, okay? All right, yes. I hope that this is clear. Now sign of scalar triple product is reversed if the cyclic order gets affected, okay? So now if you're changing the cyclic order, what will happen? It will actually give you a negative sign. I will show you right away. Yes, NK is absolutely on point. I was about to say this. So this is actually nothing but the properties of determinant only. Right? I will show you what I'm trying to say. But let us just understand this and let us later understand that what is the reason behind that, okay? A dot B cross C. Now can you see A, B, C? Again the cyclic order is A, B, C. But over here, after A we wanted what? B. But this is not B, this is C and then B. Cyclic order is not the same. That's why it is having a negative sign, right? So we can actually write it as A, B, C and this is A, C, B. So A, B, C and A, C, B with a negative sign. Okay, all right. I hope that this is clear. Yes, okay, yes, all right, all right. Now, properties of scalar triple product. Let us understand the proof of it because proof lies in properties of determinant. Hai na? Okay. So, let us understand proof. So, first of all, A, B, C, B, C, A, C, A, B. Right? So, A, B, C and this is A, B, C and minus A, C, B again. Can you see this is the very first thing where cyclic order is same? All are equal. When cyclic order are not same, minus sign will become outside. Okay. So yes. So ABC, BCA and CAB all will be equal. Why? Because cyclic order is same. But it will be equal to negative of this quantity ACB because cyclic order gets interchanged. Or BAC. Okay. All right. Yes. I hope that this is clear. And again CBA. So yes, but all these three things will still be equal. Can you see? ACB, ACB, ACB. So these three are having same cyclic order. That's why these three values will be equal. All right. So this is what about the cyclic order. Okay. All right. Now, very important, very important. So whenever you see that two of the vectors are equal or parallel, when two of the vectors are equal or parallel, then the scalar triple product will become 0. Now, how will you visualize it? So, understand the parallelepiped. So, we are having three coterminous edges. To form a parallelepiped, we need three coterminous edges. So, for example, if this one coterminous edges becomes parallel or equal to the first one, what will happen? We will not be able to form a parallelepiped. If the parallelepiped is not being formed, that means the scalar triple product is 0. Okay, so if two of them are either equal or parallel, then the scalar product or box product will become 0. Okay, all right. Yes, or what we can do is we can just simply just write A dot B cross B. So B cross B is anyway 0. When two vectors are equal or parallel, cross product is anyway 0. So that's why it is 0. Okay, all right. Yes, plane we will do it after scalar triple product, then vector triple product, and then planes. Okay, do not worry. We'll do it in today's session only. All right, now we have the scalar triple product of three mutually perpendicular unit vector is plus minus 1. Okay, all right. So whenever we have three mutually perpendicular vectors, so that means unit vectors, by the way, so I, J and K, box of this. So again, it is going to be what? Magnitude of I, magnitude of J, magnitude of K, sine theta cos phi. So when the vectors are mutually perpendicular, sine theta is 1, cos phi is also 1. So that's why it is going to be 1. Or if the cyclic order gets changed, then it will become minus 1. So I, J, K, that means the normal cyclic order is 1. But if you disturb this cyclic order, it will become minus 1. For example, I, K, J. If you interchange these two, it will become minus 1. So the scalar triple product of three, box product of three mutually perpendicular vector is nothing but plus minus 1. Okay, all right. Yes, is it clear? Yes, doubt? So please you go ahead and ask the doubt. Okay. If A, B, C are three coplanar vectors, if box ABC is equal to 0, the necessary and sufficient condition for 3, okay. All right. So basically, if three vectors are coplanar vectors, so you suppose you have to form a parallelepiped, a 3D figure. For a 3D figure, you have to need three non-coplanar, that means three vectors which are actually not lying in a single plane. You cannot form a parallelepiped on this board in a 2D plane. If you try to form it, the volume will be 0. That means the box product will become 0. So for three coplanar vector, very, very important condition. Very important condition. That box of ABC becomes 0 if these three are coplanar vector. Yes, NK, absolutely right. Agar coplanar vectors hai, then no parallelepiped is getting formed. Okay, all right. Yes, so box ABC becomes 0. Another property on your screen. Now this is actually very important property. See, suppose A plus B, CD. Box of A plus B, CD is nothing but ACD plus BCD. Right? So if you write A plus B dot C cross D. So A plus B, so this is A dot C cross D plus B dot C cross D. Okay. So again, same thing. So this is box of ACD and this is box of BCD. Correct? Clear? All right. Yes. And one more very, very important thing. Very, very important thing. What is that important thing? A plus B, B plus C, C plus A box is nothing but twice of ABC box. Twice of ABC box, right? So over here, A, B, C are coplanar vectors, then A plus B, B plus C, C plus A are also what? Coplanar vectors, Okay. So please understand this from where it is coming. So over here, A plus B, B plus C, C plus A, what is that? So suppose if a parallelepiped is having A plus B as one side, B plus C as another side, C plus A as third side, right? So box will become what? So box will actually become, this is the volume of a parallelepiped. A plus B, B plus C, C plus A are its coterminous edges. And that will become twice of box ABC. So note, understand that volume of parallelepiped with edges as face diagonals of parallelepiped with coterminous edges. Okay. Okay. Wait. Suppose we have a parallelogram. If this is A vector, this is B vector. Can you see this is A plus B? So this is actually formed by diagonal. A plus B vector is nothing but diagonal of this particular parallelogram. Okay. All right. So basically, volume of parallelepiped with edges as face diagonals, right? So this A plus B is one of the coterminous edge of another parallelepiped. B plus C is another and C plus A is another, and these three are nothing but diagonal of a normal parallelepiped. So that's why volume of parallelepiped formed by diagonals of parallelepiped with coterminous edges ABC is twice its volume. Are you able to understand it? Yes or no? Okay. All right. And you know what? You can prove it as well. You can prove it as well. Let us give me a proof. A plus B dot. So A plus B dot B plus C cross C plus A. So this is B cross C. This is B cross A. C cross C is 0. C cross A. Right? B cross C. B cross A. C cross C. C cross A. Right? So this is B cross C plus B cross A. This is 0 plus this is C cross A. And we are having A plus B dot. Now A, B, C. So this is becoming box of ABC because this A and this BC will become box ABC. Now this A and this B is 0. This A and this C is 0 because box ABA will become 0. Box ACA will become 0. Next, for B, BBC 0, BBA 0, BCA. So plus BCA ka box. So what is this? Can you see these both are equal? Why? Because this is ABC and this is also cyclic order is same ABC. So twice of ABC. This is the proof. This is the proof. Okay. All right. Clear? All right. All right. Now, you have to understand that A minus B, B minus C, C minus A, these three vectors are always coplanar. How do you prove it? How do you prove it? So, let us understand this. A minus B dot B minus C cross C minus A. So, this is A minus B and now just let us do this. B cross C. B cross A. So, minus B cross A. Minus C cross C is 0. Minus minus plus C cross A. Now, A dot BC. So, box ABC I can clearly see. And then A, B, A 0, A, C, A 0. Now, B, B, C 0, B, B, A 0 and minus BCA. So, minus BCA. So, basically these two are having same cyclic order. So, these two will get cancelled out because these two values are equal. So, ABC minus BC. Gone, gone, gone. Right? Clear? I hope that this is clear. So, these vectors are always coplanar because without any condition, this particular thing, the box of this is always 0. Okay. So, this is one more property related to scalar triple product. Okay. All right. Let us move on to the next very important property and we will solve a question on this as well. Okay. All right. So, box ABC whole square. You know box ABC whole square. So box ABC, how you calculate? By finding determinant. So box ABC whole square, that means exactly two determinants. Right? Exactly two determinants. So now let us just multiply the matrix multiplication, you know, the usual multiplication. A1, A2, A3 will actually get multiplied with A1, A2, A3. So A1, A1, A2, A2, A3, A3. So A1, A1, A2, A2, A3, A3 is what? A1 square plus A2 square plus A3 square, that is nothing but A dot A. Now this will get multiplied with B1, B2, B3. Now you must be wondering, ma'am, what are you doing? Matrix multiplication, we don't do it like that. So row 1 and column. Ma'am, row with column. So yeah, I know, but what I'm trying to do is yes, NK, you have done actually advanced PYQs as well. This property actually came in advanced PYQ. We will do that as well. I am taking transpose of this particular determinant, and then what will happen? The row will become column. So this is column number 1, column number 2, column number 3. Let us assume like this. So this is row number 1, row number 2, row number 3. So row 1 will get multiplied with column 1, so A dot A. Now row 1 with column 2, so A dot B. This is your, and row 1 with column 3, A dot C. Now row 2 and column 1, so B dot A, B dot B, and B dot C. And similarly C dot A, C dot B, C dot C, like that. Okay. Alright. So a box ABC square actually is this also. This is actually very important, and when you get the question now, when actually the question arrives, you won't be able to think of this property. It is very difficult to think a property box ABC square is given in the terms of dot product of individual vectors. Okay. All right. A dot A dot B, A dot C. Now let us do a question. It was there in IIT JEE 2008. So NK is saying that this question was there in advanced as well. So the question says edges of a parallelepiped are of unit length and are parallel to non-coplanar unit vector ABC. That means this ABC are only coterminous edges which are unit vector, and it is given that A dot B, B dot C, C dot A is equals to half. Then the volume of parallelepiped is what they are asking. Volume of parallelepiped, we know that box of ABC box and magnitude. Right? Okay. So this is going to be now let me just calculate box of ABC square. Understand the property has a square because so many people forget the square. Now that is going to be A dot A. So both are unit vector, then A dot B, then A dot C, then B dot A, B dot B, B dot C, C dot A, C dot B, C dot C. Now A dot A would be 1 because it's a unit vector. So this I can delete it and I can write it as 1. Right? This is your 1. What about A dot B? It is given. So A dot B, right? And B dot C also. And C dot A, and C dot B. Everything else is half. So this is half, this is half. This is half, this is half. Half, half. And B dot B is 1, B dot B is 1, bracket close. So you just have to solve this particular determinant. Let us solve this determinant. Yes. Okay. So this is what your determinant is. The moment you solve it, you will get half. Now volume of parallelepiped, who is going to tell me? Volume of parallelepiped. So square root of half. So 1 by root 2 is the volume. There were so many people. There were so many people in JEE Advanced 2008 who were like, ma'am, we knew this property. First of all, there were so many people who were not aware about this property, or who were aware but they didn't understand that when to apply this property. I'm not talking about them. Let us come thoda sa on upper level. There were so many students who got this half and the volume they written is half. But it is 1 by root 2. These are the silly mistakes which are very painful for you and for me as well. Right? Why it is painful for me? Because you know there is so much of hard work in this small little things, and that one question arrives and then the whole JEE Advanced thing go in waste if you are doing these silly mistakes. If you don't know it, I am fine. If you have not studied it, I am fine. But I have taught it my time, my resource. You have studied your time, your resource. And then when the paper comes, you do these type of silly mistakes, then everything goes wasted. Okay? So either you do not study, or if you are studying, then please do not commit these stupid mistakes. Okay? Because that's what hurts. Okay? All right. Now let us talk about tetrahedron. Tetrahedron is actually a figure where we are having how many triangles? So we have a triangular base. Can you see this is your triangular base? And there is one top point. So this is one triangular base. This is second triangular base. And this is third triangular base. Okay. Yapping. What does yapping mean? I don't know this word. What does yapping mean? Okay. So basically, one triangular base, you can clearly see it is in bottom. Then we are having 2, 3, 4. So 1 plus 3 triangular face becomes 4. Okay. So this is your tetrahedron. So it is actually placed in a plane surface. So if I would have that tetrahedron, I would have brought it over here. But yes. So yes, this is your floor. You can actually keep that in that. Okay. How to calculate volume? So you know cone. What is the area of cone? Who is going to tell me? Area of cone, quickly. Area of cone. So the area of cone is 1 by 3 pi r square h. कैसे आया ये? How did it come? Why is it 1 by 3 pi r square h? So basically cone is having the base. Base of cone is circular. So 1 by 3, why 1 by 3? Because actually it is not a complete figure. It is a conical figure. Similarly, it is also similar to conic. Right? So again, 1 by 3. No, who is saying 1 by 3 pi r cube? No. 1 by 3 pi r square is area of that circle, which is the base, and height is height of the cone. Similar thing we are going to apply in tetrahedron. 1 by 3 area of this base into height. 1 by 3 area of this base into height. So volume of tetrahedron would be what? Can you see 1 by 3 base area, that means area of this particular triangle, you can clearly see, into height. Now base area of this triangle. So if you know all three positions of a triangle, so A cross B, B cross C, C cross A, and half is gonna give you area of this. Right? And height, how to calculate height? So height will be nothing but this particular quantity over here if I mark it and if I drop a perpendicular. So to calculate height, we need a projection of this A vector, or we can say B vector. Right? Or we can say C vector. You can just take any vector, but projection of any of these three vectors on this N vector, which is that area vector. What is area vector? A, B, C. This N vector is nothing but area vector, which is perpendicular to A cross B, B cross C, and C cross A. Right? So what we need to do is, we need to take projection of A vector on N vector so that it will become this particular height. Okay? Alright, so yes, height is projection of A on N. So this is your height, A vector, A dot N upon N. Right, so now this is your base area. If you multiply everything, what you are going to get is 1 by 6 magnitude of box ABC. Yes, 1 by 6 magnitude of box ABC. Alright, this is what it is. This is what you have to figure it out. All right. Now, can you see this vector is A vector, this is B, this is C, this is D. So this vector you can calculate AB, AC and AD, right? So now the volume of this particular tetrahedron, this is a slightly different nomenclature I have given to this particular tetrahedron because previously this point was O. So A and then B and then C. So box ABC upon 6. Okay. All right. Now this is what? 1/6 AB, AC and AD will be the volume of this tetrahedron. AB is B minus A, AC is C minus A, AD is D minus A. Please do not get bothered about, please understand this, that one should be the common point. AB, AC, AD. Okay, please don't get bothered what to write first, what to write second, because we have a mod over here. So positive, negative sign, do not worry about it. Okay, so this is your volume of tetrahedron, and now we will solve a question. If the vertices of any tetrahedron, A vector, so A vector is this, B vector is this, C vector is this, and D vector is also this. So 4 vectors are given. We need to find out its volume. So yes, A, B, C, D are already there. We have to find AB vector. That will be done by B minus A, right? So B minus A. So can you see AB vector will be 3 minus 1, 2. Okay, sorry. 3 minus 0 and then 0 minus 1 and then minus 1. So this is your AB vector. What is AC vector? So C minus A will be AC. So this is your B minus A. This is your C minus A and this is your D minus A. Correct? AB, AC and AD vector. So 1/6 box of AB, AC, AD. So 1/6 determinant of this particular value will be -6. Okay. All right. So this is your volume of this particular tetrahedron. I hope that this is clear. Yes. So required volume is 6 unit. Very basic, direct question, to the point question. Right? No twist, no googly. All right. Now vector triple product. Let us now start vector triple product. Shall we start? Vector triple product. Okay, scalar triple product done. Volume negative. One student is saying yes. Volume negative. That's what it is. So that's why volume of tetrahedron is magnitude of it. That's what I was saying. Please do not hesitate in actually writing anything. AB, AC, AD or BA, BC, BD, or what you can do is AB, AD, AC. So order will not matter. Why? Because over here, basically we are doing this. Again, we are taking modulus. Just like in area we do it, determinant half of x1, y1, 1. So finally we take a mod. Why? Because volume cannot be negative. So 6 units. Okay. It might come negative. And please understand this. So whenever there are hidden things, just like in area, suppose they are giving you volume of tetrahedron is this, and find this vector, missing thing of this vector. So please take mod. Because once you take mod, you have to apply plus minus sign and you will get 2 values of that unknown quantity. Please do not forget taking mod, because this is the very most common silly mistakes which people do even after actually knowing the thing, but in the exam time they do the silly mistake, right? Silly mistake means that you know it but you are stupid, that you are doing that mistake over here. Okay. Chalo. Vector triple product. So vector triple product is actually very easy to guess. A dot B cross C was scalar. So A cross B cross C is vector, and this is actually a vector quantity. Okay. And it is defined as a vector which is coplanar with these two combined vector. So A cross B cross C is a vector quantity, right? Suppose we assign it as a U vector. So this whole thing is suppose is a U vector. So u vector is this. Okay, this is your u vector, and now this u vector is actually coplanar with A and B but perpendicular to C. U vector is coplanar with A and B and perpendicular to C. Very, very important point. Very, very important. That's why I am saying it 2-3 times. Okay. So yes. So you have got 3 vectors. Okay. And now A cross B cross C. So first of all, B cross C is what you are looking for. So B cross C is this. And now this you have to take cross of this vector and this. So you are going to get the finally A cross B cross C. Right? So coplanar, so A cross B. Or what you can do is you can combine these two. So A cross B ke saath coplanar and perpendicular to your C vector. Okay? So yes, this is going to be your A cross B. So can you see? It is lying in this particular plane, but it is perpendicular to your C vector. Right? Are you getting it? This A cross B cross C, the final vector, can you see it is perpendicular and it is lying in these two planes? Visually, are you able to visualize it? So if this particular vector A cross B cross C is in coplane, lies in plane with A and B vector, so can I write XA vector and YB vector? Can I write XA vector and YB vector? Definitely, by theorem in plane. So if any vector lies in plane of two given vector, that can be written by XA vector plus YB vector. Okay, all right, linear combination, whatever you want to call it. And now how to open A cross B cross C? Very easy. Please understand, I want your maximum attention over here. Okay, A cross B cross C. So now we need to take dot of first and last, always A dot C. So A dot C will be written over here, and now A dot C is already there. Now whatever vector is left, this B is left, that will be written outside. Please understand, A dot C is dot product and B vector is actually multiplied with this scalar quantity. There is no dot over here between this. Dot is here, not here. Now minus sign. Now A has performed his action with C. Now is the time that A and B becomes merged. So A dot B, and outside that we have C vector. So this is how you expand triple product. Okay. Now let us understand this. How to expand this? Again same. First and last. So B dot A, and outside we have C vector. Now because B and A are done with together, so now it's the time that C and A will be dot together. C dot A, and outside we have B vector. Okay, all right, clear? I hope that this is clear. Expansion formula for triple product. Now properties of triple product, let us understand some property. A cross B, B cross C, C cross A ka box. It is box. A is box ABC square. Now you must be wondering, again ma'am, triple product you're explaining and you're introducing box in it. Let me just show you that why it is a property of triple product. Because if you expand and if you try to write, so this is A cross B dot this cross this. So if you carefully observe this, actually this would be nothing but A cross B dot, or basically what you can do is, yeah. So cross product of these two dot this. Anything you can write by the property. Right, because dot and cross are interchanged with each other. So yes, we are going to prove it. Proof. So let us take the left hand side and understand that what it is trying to say. Okay. So now can you see, this is not even triple product. This is basically vector product of 4 vectors. But we don't have understand this. We don't have read this concept. So what we will do is we will just write this particular vector as a U vector. Now we have U cross B cross C. So it is very easy to open U cross B cross C. We have just seen how to open vector triple product. So U cross B cross C will be U dot C, and outside we have B vector. U dot C, then we have B vector, and then U dot B, C vector. And we have dot C cross A. And now is the time you should put the value of U. Yes, you should be putting the value of u over here. What is u? A cross b. So in the next step, you just put a cross b. Okay. So yes, a cross b, if you put, what do you get? A cross b dot c, and you are having b vector minus c. So a cross b, u vector is a cross b dot b. Okay, so this is gone. This is actually 0. Right? This is no need to write it. So this is dot c cross a. So this is what? Box ABC, and this is b dot c cross a. So BCA. B dot C cross A. BC again ACB. So ABC and ABC both together. So this will become ABC square. And now we know this property from scalar triple product, that ABC ka whole square is this. How do we denote vector triple product? So it is very easy. A cross B cross C. So if you write this way, A cross B, it is actually denoting a vector which lies in plane with A and B but perpendicular to C. But if you write this way, both are very different, by the way. So this vector, this thing is lies in plane with B and C but perpendicular to A vector. So these two are very, very different things, unlike scalar triple product. I hope that this is clear. No. Egal. What is your name? 𝑬𝒙𝒑𝒔. अतरंगी सा नाम है. But no, there is no certain notation, just like scalar triple product we use box. But for that, A cross B cross C only. All right. And now, if A, B, C are no non-coplanar vectors, what does actually that mean? Let's go back. So suppose box ABC is 0. What does that mean? Who is going to tell me? Right now we have studied. If box ABC is 0, that means ABC are coplanar. So if box ABC is 0, that means A cross B, B cross C, C cross A is also 0. That means these three vectors are also coplanar. So that's what it is saying. That A, B, C, if they are non-coplanar vectors, then A cross B, B cross C, C cross A will also be non-coplanar vectors. Right? Okay. Acha, it's 𝑬𝒙𝒑𝒔. Okay. 𝑬𝒙𝒑𝒔. Okay, all right. Now, vector triple product is a vector quantity. It is very obvious. Just a reinforcement of the thing. And also, I have already told you A cross B cross C is not equal to A cross B cross C. Why? Because this represents a vector which is lying in plane with B and C and perpendicular to A. You know, the vector completely, the position, 3D visualization is different. And this lies in plane with A and B but perpendicular to C. So these two are actually very, very unequal. And now, very, very important thing. Very important thing. So suppose somebody comes to you and asks you that you have to write a vector which is coplanar with A and B and perpendicular with C. So how will you write? So you will be saying, okay, aren't you saying the definition of A cross B cross C? So unit vector which is coplanar with A and B, that means A cross B will be together and perpendicular to this, to C. Now you are looking for unit vector. So this is actually the direction we have figured out. For the unit vector, we have to divide by the same magnitude, plus minus sign we have to apply. So whenever someone asks you, very important, because from here to here going is very easy. That A cross B cross C, ma'am, we know. A cross B cross C is A cross B. If they are together, that means coplanar with A and B and perpendicular to C. But if I tell you this, there is a vector which lies in plane of two given vectors and perpendicular with the third vector, then you will be like, okay, ma'am, okay. A cross B cross C, A cross B together. All right. है ना? I hope that this is clear. ठीक है? No, I don't have that accent. I was faking that accent. Chalo, I was having fun, thoda sa. Chalo, all right. Then we have this, okay? We have this question. Let us do this. I cross J cross K. Now, J cross K. So, J cross K is actually I. And I cross I is 0. Ooh, so this is 0. K cross I is what? J, J cross J. Oh, oops. So, okay, now we are getting it. Now we are getting it. This is actually 0 plus 0 plus 0. All right, easy peasy question. Now is the time. So vector ke additional topics we have successfully finished. Now is the time we should be starting planes. Okay, are we ready for planes? Yes. And after that we would be doing what? Calculus. All right, ready, steady, go. So plane, let us understand what is the basic of a plane. So suppose you are having 2 points A and B. Okay. Line joining 2 points on a surface lies completely on it, then a surface is a plane. So basically, this surface, you can clearly see this is a plane. This smart board is a plane. Okay, so plane is actually a 2D figure, not a 3D figure. It is a 2D figure. Okay. So if the line joining any 2 points on a surface is perpendicular to some fixed straight line, then we will call it as a plane. All right. So basically, I have this. So what is the condition? Suppose this is my laptop, right? This is my laptop. This is my laptop. Yes. If you are actually able to make a perpendicular of this particular laptop, then you will call it as a plane. This surface is plane and this we will call it as a normal of that plane. And this normal of that plane is, by the way, movable. And one more thing, you must be wondering, okay ma'am, this is the plane? No. Sometimes we mistake. Basically, a plane is an infinite plane. This laptop is actually a segment, a portion of a plane. But if I'm calling something as a plane, this is actually spreaded infinitely in this direction and in this direction and in this direction and in each and every, all 4 directions. Okay, so that is a plane. Suppose we have XY plane. Yes. So suppose we are having XY plane. So can you see XY planes goes up to infinity? Okay. Actually, this smart board is very heating up. The lights and smart board is heating up. So I need to reduce the temperature. Okay, so now you know that for a plane, a normal should exist. Now let us understand what is the equation of that plane and how to write the equation of any plane. Okay? So now, yes. So suppose we are having 2 points. First is the point given to you, x1, y1, z1, that is a fixed point on a plane. And this is a moving point, just like line. We take a moving point on that line and we take a fixed point on that line, right? And now we need a perpendicular or a normal to this plane or normal vector to this plane. So you just tell me in the chat box, for a straight line, you have studied straight line. To write an equation of a straight line, what do you need? A point and its direction, that is slope. If you have point, if you have slope, you will be able to write the equation of line. But for plane, what do you need? For plane, again, you need a fixed point, similar thing. But in the plane, you don't need direction of plane. But rather, what you need is normal to that plane. vector which is perpendicular to that plane. That's what you need. Are you getting my point? Yes? Clear? So yes, if you are having it, then writing equation of normal would be a cakewalk for you. So suppose normal vector is ai cap plus bj cap plus ck cap. All right, yes. So this is your A, which is I cap ka coefficient, B is J cap ka coefficient, C is K cap ka coefficient, and this is x minus x1, x is x, x1 is fixed point, y minus y1, z minus z1, this is the equation of that plane. Okay, so very easy to write equation of the plane. So this is actually which form? Normal and point is given. Then you can quickly write the equation of the plane, right? Now, general form of the equation of plane. General form of the equation of plane. All right. General form of the equation of plane. So, general form ke liye, basically, we just need ax plus by plus cz is equals to the general form means what? Whenever you heard this general equation, general form, so that means what all terms that equation can have. So it can have a x term, a y term, a z term and a constant term. That's it. And over here a, b and c is nothing but normal to that plane. Coefficients of normal to that plane. Right? So this is the equation of plane. Now let us understand the equation of a plane, xy plane, yz, zx. Equation of plane which is perpendicular to xy, yz, zx. Like that. One by one. If you have yz plane. So for yz plane is this. This is x, this is y, and this is your z. That means this particular plane. Yz is this plane. This plane. Okay. So yz plane passes through origin. Okay. Clearly yz plane passes through origin. And the normal vector to this particular plane is what? I cap, that is 1, 0, 0. This is your normal vector, right? So if I write 1 into x minus 0 plus 0 into y minus 0 plus 0 into z minus 0 is equals to 0. So what you are going to get is x is equals to 0 clearly. So okay, equation of yz plane is x equals to 0. Now we can quickly confirm. Equation of xz plane will be what? Y is equals to 0. Equation of xy plane will be z equals to 0. Bolo, clear hai? Yes. Are we getting all three? Right? Because this is the plane. If this is your planar, then I cap will be 1, 0, 0. And now equation of plane which is parallel to x-axis. Equation of a plane which is parallel to x-axis. So this is your x-axis and this is your plane. Parallel to x-axis. Okay. So the point on this plane, if it is parallel, it passes through y-axis. And we know on y-axis, so this is 0, any point y, y0, 0. Because on y-axis, everything else is 0. Right? And I am looking for a perpendicular. So this j cap will be perpendicular vector. So this is going to be 0, 1, 0. And then point is x minus 0 plus y minus 0 plus. So this is going to be by plus cz is equals to d. Okay, sorry. Parallel to xy plane now. So actually parallel to this plane. This is your plane and this is your vector. And this vector is actually perpendicular to x-axis. Perpendicular to x-axis means that dot product with that will be 0. So yes, bj cap plus c k cap. This is your perpendicular vector. So if you take dot product with I cap now, because it is perpendicular to x-axis, it should become 0 and it is becoming 0. So b comma j, that means 0 comma b comma c is the normal vector and the point so by plus cz is equals to d. Yes. Right, parallel to x-axis. Now we know the pattern. Parallel to y-axis will be what? So y will be missing. So ax plus cz is equals to d. Parallel to z axis will be what? Ax plus by is equals to d. Right? Clear? So this is general form of equation of plane. Let us have a question over here because we are doing theory, too much of theory, right? So let us do it. 3 planes are there. Which of the following is true? So over here 3, 15, 21, okay, and 2, 10, 14. So P3 and P1, because the coefficients all are positive, if I take 3 common, so 1, 3, 3 5s and 7. If I take 2 common, 1, 5, oops, So normal vector of P1 and P3 are parallel. What does that mean? P1 and P3 both are parallel. Yes? All right. Clear? I hope that this is clear. So P1 is this because we have taken 3 common. From here we have taken what? P2 is same. From P3 we have taken 2 common. So clearly P1 and P3 are looking exactly the same except the constant term. That's why P1 and P3 are parallel. Okay? All right. Now intercept form of equation of plane. So let me talk about the straight line. So straight line may you have seen that form where this x-intercept is A, y-intercept is B. So x upon A plus y upon B is equals to 1. Same goes with plane, but with a little bit twist. So suppose that plane is intersecting x-axis at A, y at B and z-axis at C. So this plane will actually not look like this, but the intersection thing will look like this. The plane is actually extended, right? But the plane passes through these 3 points and then it is extended. So the equation will be x by A plus y by B plus z by C. This is the new member is equals to 1. So this case was happened with line and this has happened with plane. Okay. All right. Clear? I hope that this is clear. The equation of a plane parallel to x plus 5y minus 4z plus 5 is equals to 0. So there is now we are having a question. Equation of plane parallel to this and cutting intercept on the axis whose sum is 38. So let us just write it. So x by A plus y by B plus z by C is equals to 1. That is first thing. And now A plus B plus C is what they are saying is 38. Okay, and also it is parallel. So if it is parallel, so 1 by A clearly will be 1. 1 by B clearly will be 5 and 1 by C clearly will be minus 4. So A will be equals to 1, B is 1 by 5 and C is minus 1 by 4. If you put the values, no. Sorry. Let us do it one more time. What we can do is x plus 5y minus 4z is equals to d. Let us assume that this is the equation of plane which is parallel to this. Okay. And now what we will do is x upon d plus y upon d upon 5 minus, so plus z upon d upon minus 4 is equals to 1. So this is d plus d by 5 minus d by 4 is coming out as 38. So if you solve it, you are going to get 20d plus 4d minus 5d is equals to 38. And from here, 19d is equals to 38 into 20. So 19 into 2, so d is coming out as 40. So what is the equation 40 wali? Option C. Yes? Clear? So what we have done over here is equation of plane parallel to this. So the very first thing is, okay, we know how to write equation of plane parallel to this. Just change the constant, just like the straight lines, two parallel lines. So if a line is ax plus by plus c is equals to 0, another line which is parallel ax plus by plus c1 is equals to 0. You just change the constant. So that's why this is d. है ना? Plane parallel to this will be x plus 5y minus 4z is equals to d. Now you're just looking for d. That's it. You're just looking for d. And by the options as well, you can clearly figure out that if this particular, all the coefficients of x, y, z are this only. You are looking for d. That's it. Okay. And now how will you tackle? Now what we will do is we will convert this in intercept form. What is the intercept form? X by a plus y by b plus z by c is equals to 1. A, b, c are what? Intercepts. So let us convert this equation in that form. Why don't we do that? So this d will come in the denominator, x upon d. Then 5y upon d. So this 5 will come to d by 5. So that 5y by d. And minus, so d z upon minus d by 4 is equals to 1. Now this is your x-intercept. This is your y-intercept. This is your z-intercept. If you add, what you are going to get is d is equals to 40. And once you get 40, you are done. Right? Yes. And if you have not liked the session, please do like this session. Right? What are you waiting for? Okay. Now we have normal form of plane. Yes. We are having normal form of the plane. Alright. So normal form of plane is absolutely very, very easy, just like your normal form of line. है ना? So if normal form of line में you should know the distance of perpendicular distance from origin to the line. But this time what you should know is perpendicular distance from origin to this particular plane. And if you know that, the normal form of line is very easy. So Lx plus My plus Nz is equals to P over here. Okay. And L, M and N are direction cosines of normal vector. Cosines, understand. And P is nothing but perpendicular distance from origin. That's it. That's it. Game over. Game over. LM and R DCs of normal, P is equals to distance of plane from origin. Now we can convert it into general form as well, right? General form is this. So A, B, C, right? So divide both sides by this. So you are going to get this. So in case you are having general form and you have to convert it into normal form, what is the procedure? So suppose you are having x plus y plus z is equals to 3. This is the general form. And now you have to convert this in normal form. What you will do is you just have to divide both sides by square root of x ka coefficient, y ka coefficient square, z ka coefficient. Same over here. So this is x by root 3 plus y by root 3 plus z by root 3 and 3 by root 3. So over here 1 by root 3, 1 by root 3, 1 by root 3 are L, M and N. L, M and N, that is direction cosines. Over here 1, 1, 1, 1. Originally 1, 1, 1, 1 was direction ratio, but what you wanted was direction cosine. And this now 3 by root 3 will represent distance. OA and normal will have same DCs, yes. OA will have same direction ratios, let us call it for like confusion, but it will have same direction. OA direction and element direction will be exactly same, okay? Definitely you are absolutely right. Constant term on the right side should be positive. That's what you have to understand. Okay. Equation of plane upon which the length of normal from origin is 10 and direction ratios are given 3 to 6. We don't need direction ratios. What we need is direction cosines for the normal form. So that would be 3 upon square root of 9 plus 4 plus 36. Then we have 2 upon square root of 9 plus 4 plus 36. Then we have 6 upon square root of 9 plus 4 plus 36. So I guess this is 3 by 7, 2 by 7, 6 by 7. So 3x plus 2x, 2y plus 6z upon 7, 7, 7. And length of distance is given actually. Upon which length of normal from origin is 10. So this is 10. So this is your final solution. So equation of plane writing is very easy. Yes? Clear? Or if what you can do is you can just write this is your general form. This is general form, this is normal form. Okay? Now equation of plane passing through 3 points. So suppose you are given with 3 points which are lying on the plane. How will you calculate the equation of plane? So by the determinant method you can easily calculate, because these three vectors. So yes, can you see A, B and C are coplanar? So these 3 points are coplanar. Let us take one more point x, y, z in same plane, and now by the help of this vector let us form 3 vectors. So first vector is what? This vector, r minus a vector. X minus x1, y minus y1, z minus z1. Second vector could be what? This, x2 minus x1, y2 minus y2, z2 minus z1. And third will be x3 minus x1, y3 minus y1, z3 minus z1. So just form a determinant, make it equal to 0 because of the coplanar. Yes, EM set classes I am going to take. Pakka, sure. We are planning, just now spoken with Shreyas sir. Do not worry. X minus x1, y minus y1, z minus z1, rho 1. Then x2 minus x1, can you see? Here the last thing is common. So this is x minus x1, x2 minus x1, x3 minus x1. So this thing is x1, this is y1. Right? So this is how you are going to form a determinant and make it 0. If you solve it, what you are going to get is the equation of plane passing through these 3 points. This is the procedure. So this is the procedure oriented question or concept. Right? Again, a question is there. So what we will do is, first of all, this is x1, y1, z1. This is x2, y2, z2. And x3, y3, z3. Let me just tell you how to form that determinant. So determinant, x minus x1. So x minus 1, y minus 1, z minus 1. x2 minus x1. So that is going to be 2 minus 1, 1. 1 minus 1, 0. Minus 1, minus 1, minus 2. And x3 minus x1. Now 3 minus 1 is 2, 2 and plus 1. That's it. Just expand it. Go ahead. Go ahead. Open it. You are going to get equation of the plane. And yeah, so this is what you are going to get. That's what I was telling you. Right? 2 minus 1. 1 minus 1, 0. Then minus 2. Then you have 2, 2 and minus 1. Yes. So once you expand it, you are going to get this particular plane. Okay? Clear? Now condition of 4 points to be coplanar. So it is the same condition. If you are given with 4 points, what you will do is same thing, exactly same thing. It's just that in previously you were getting 3 points, 1 x, y, z you have assumed, but this time you are getting 4 points. So again, these are lying on the same plane. So that means that the determinant formed by these 4 points or these 3 vectors will become 0. So yes, so this is it. Here x, so this is going to be x2 minus x1, y2 minus y1, z2 minus z1, this vector. Or what you can do is, if these three vectors, if 4 points are given, form 3 vectors, and these 3 vectors become coplanar, that means box becomes 0. Same. Box 0 means determinant 0. Same thing. Both are exactly same only. Clear? All right. Now there is a very important concept, which is foot of perpendicular from a point to a plane. Direct, you have to remember direct formula. Let me just show you the direct formula. Okay, so over here, if you have point 1, 0, 2, and you have a plane, and you are here for foot of perpendicular, let us assume as alpha, beta, gamma. And this is your plane 2x plus y plus z is equals to 5. Then what will you do? What will you do? What is the formula? So let me just show you. Alpha minus 1 is equals to beta minus 0 is equals to gamma minus 2 whole upon, you have to write coefficients 2, 1 and 1. Coefficients of the plane, and that will be equals to minus 1 because you are looking for foot of perpendicular. If you were looking for image about the plane, you have to write minus 2. That's it. That's the only difference in the formula. So right now, foot of perpendicular, so minus 1. And now you have to put this point in this plane. So 2 1s are 2, 0, and then 2, minus 5, whole upon a square plus b square plus c square. Please understand, there is no square root. So a square, that means 2 square plus 1 square plus 1 square. 2 square plus 1 square plus 1 square. That's it, my dear students. This is the formula. Now, alpha minus 1 by 2 is equals to beta is equals to gamma minus 2 is equals to minus of. Can you see 4 minus 5? So plus 1 upon 4, 5, 6. 1 by 6. So it is going to be 1 by 3 plus 1. Alpha is equals to 4 by 3, comma beta will be equals to what? 1 by 6. And gamma will be equals to what? 1 by 6 plus 2. 6 2s are 12, 13 by 6. All right? Yes. So now you are done. I guess 4 by 3, 1 by 6, 13 by 6 is sitting in option B, right? And if for the same question, they were to ask ki, okay, the image of a point about this plane, so just the small difference, instead of minus 1, you have to write minus 2. This is the procedure. Okay, I hope that this is clear. How to calculate foot of perpendicular? Yes. All right. Okay. Yes, how many more topics? So basically after that we are having family of lines, and after that we have mean value theorems. 2 more topics. 2 more topics. Okay. All right. Now image of a point with respect to a plane. So again, I have already told you this formula. We just need to do a question on that. If the mirror image of this point with respect to this plane is this, then we have to figure out this. Okay. So again, 1, 3, 5. Very easy. This is your plane, which is what? 4x minus 5y plus 2z is equals to 8. And now you are looking for image, which is alpha, beta, gamma. So alpha minus 1, same thing, upon beta minus 3, gamma minus 5. Upon me, what do I have to write? 4 minus 5 and 2. And on the right hand side, minus 2 because image. Okay. So minus 2. Beta, limit as sum, I have made a separate video on it. So you can just refer to that video because I have taught that in JEE Mains only. Even that it is a deleted topic, but I have taught in JEE Main. Why? Because in session 1 they were giving it. So but I will share after this. I will show you where exactly of a 2-3 minute video I have formed. Tangent and normal in conics. Tangent, yes, tangent and normal in conics is still left, but tangent and normal application of derivatives we will cover today. Okay. All right, yes. So now -2, you have to plug in this point over here, which is 4 minus 15 plus 10. So 4 minus 15 plus 10 upon we have square root nahi hai, 16 plus 25 plus 4. Yeah, so that is it. Alpha minus 1 by 4 is equals to beta minus 3 upon minus 5. Gamma minus 5 upon 2 is equals to minus 2. Okay. So we are having 14 minus 15 minus 1, so plus 2 ho gaya upon 16 plus 4, 20, 45. Yes, so if you solve it, you are going to get the final answer. Okay, you are looking for alpha plus beta plus gamma. It is actually very easy to solve right now. Okay. All right. Yes, so let me just show you the calculations over here. Yeah, so these are the calculation. Alpha is 13 by 5, beta is 1. So this is the final thing, okay? This is what we were doing. Again, 4 minus 50, oh, minus 8, we forgot. Yeah, 5 to the 10. Yes, we did something wrong over here. But anyway, alpha, beta, gamma like this, and we are done. So now your answer would be what? 13 plus 5 plus 29. That will be matching with option A. Clear? Yes? Now we are having distance of a point from a plane. Let us take a quick break. Kya? Let us take a break. Is it okay? Okay. So let us take a quick 10 minutes break. Okay, 10 minutes break. Let's do it. 10-minute break. So kya time ho raha hai? Let's meet at 5 PM sharp. Hmm, 10 minutes. Okay. Come back, come back, come back. आ जाओ, वापस आ जाओ को तेलुगु में what do we say? What do we say? Come back. What do we say? Come back in Telugu. Come back. Come back Telugu. In Telugu or in Tamil, if you can teach me some Telugu, Tamil, Malayalam as well before starting. Right? Because JEE Advanced is thoda sa intense, so I just wanted to make it light. If somebody can teach me. Nen vachasa. Vapas aa jao. Come back. Ko we say nen vachasa. Chalo. Nen vachasa. Everyone. Right now. Everyone. Nen vachasa. Am I speaking it right? Chalo. Distance of a point from a plane. So you know that you have already studied, you have a straight line, you have a point, so distance of a point from a line, you know, same, exactly same, ditto same, just additional z will be there. So equation of plane is given, right? Okay, and now you are having a point from which you are looking for the distance, okay? All right, so this is x1, y1, z1, and this is your plane. And you are looking for this distance, and this distance will be what? So you have to put this point in the plane. x1, y1, z1, you put it in this plane. So ax1 plus by1 plus cz1 minus d upon square root. Here we are having square root. A square plus b square plus c square. Okay, very easy. All right, so nenu vachasa. Telugu mein nenu vachasa. ठीक है. Okay. Now, angle between a line and a plane. Okay, please understand this very nicely. Suppose you are having a line and you are having a plane, right? So, which angle actually you are looking for? This angle, theta, right? Okay, but here is the catch. Here is the catch. What exactly you know about this line and a plane? So what you know is, you actually know direction of this line. So this will be this direction. Direction of line you know, because if you know the line, you know the direction of the line, either cosines or ratios. But for the plane, what you know actually is the perpendicular. So let me just thoda sa delete this. So that it doesn't look perpendicular. It should not look perpendicular. Yeah. So this is your line. And this is the angle which you're looking for. But now you know that you have normal vector to this plane. You know this normal. And you know this as well. Right? You know this normal. You know this as well. Sorry, not this. Sorry. Erase. This is name. You know this. You know this direction of a line. So this is alpha. Okay. So what you are looking for is theta. Your answer is theta. But what you can calculate is actually alpha. Right? You can calculate as alpha. Why? Because you know the normal vector, you know the direction cosine of this line. So angle between these two will be alpha. Are you getting my point? Right? So if you calculate alpha, how do you calculate it? So suppose you are having this ax plus by plus cz is equals to d. And the direction cosines of this will be a1x plus, so a1 comma b1 comma c1. So this line equation, let me just write the equation of this line. Right? So this is x minus x1 upon a1 plus equals to y minus y1 upon b1 is equals to z minus z1 upon c. Right? So now cos alpha would be equal to what? A1 dot product plus b1 plus c1 upon square root of a square plus b square plus c square. A1 square plus b1 square plus c1 square. So this is actually cos alpha is equals to A vector dot B vector upon magnitude of A, magnitude of B. Are you getting my point? Yes. But what you are looking for is theta, not alpha. So alpha, actually theta plus alpha is what? This is 90 degree because this is normal. So alpha is nothing but 90 minus theta. So what you can do is you can just replace this alpha. So this is cos 90 minus theta. Cos 90 minus theta is sin theta. So actually this quantity will give you sin theta. Right? This is the difference. There is a difference between angle between a line and a plane. Right? Let me just show you nicely now. So equation of plane you know. Ax plus by plus c. Equation of line is this. Okay. So this is your plane, normal to this plane. So this will be A, B and C are the direction of the normal. A1, B1, C1 are the direction of that line. Right? So yes, sin theta will be equals to this. Sin inverse will be equals to this. Right? Getting it? So you just have to keep that in mind. Whenever you calculate the angle between line and the plane, the left hand side will not be the cos theta but the sin theta. Okay? Alright? And now this time things will get twisted. Things will get changed. Because sin theta. So now if your angle, if your lines are parallel, that means theta will become 0. That means A1, B1, C1 dot product will be equal to 0. So whenever dot product between line and plane becomes 0, they do not become perpendicular but they become parallel. Right? Whenever dot product, because theta becomes 90 degree, that means this line becomes perpendicular over here. Clearly, if theta becomes 90 degree, so this theta, this angle, so that means this line will become parallel to the normal. Right? So condition of line for to become parallel to the plane is dot product 0. Right? Parallel mein, in this case dot product will be 0. This is actually very different because dot product 0 means what we do is perpendicular. But no. Line and plane mein dot product 0 means parallel. Okay. Alright. Clear? Now if they are perpendicular, what does that mean? If they are perpendicular, that means the ratios are equal. If they are perpendicular, suppose line is perpendicular to the plane. What does that mean? That the line direction and the normal direction are same. What does that mean? That this is proportion to this. So A by A1, B by B1, C by C1 is are equal. All right. Okay. Condition for a line to lie in a plane. Condition for a line to lie in a plane. So let the equation of plane is this, right? Equation of plane is already given to us and a plane is also given to us and equation of line is also given to us. Okay. So for a line to lie in plane, so that, see, understand, a line is lying in that plane, right? So basically this x0, y0, z0, this point is lying on this line and line is lying on the plane. So that means point will lie on the plane. Point will lie on the plane, right? Suppose I am having a container. Okay, white container. And inside that, I will keep a box of laddus. Laddus. Right? So can you see this laddus are inside this white container? Why? Because laddus are inside this box and the box is inside the container. That means, can we say that laddus are inside this container? Yes. So if a point is lying on the line and line is lying on the plane, so can I say this point is actually lying on the plane? So this x0, y0, z0 will satisfy this particular plane. That is the first thing over here. All right. And yes, one more thing. So for this line, can you see A1, B1, C1 are parallel to this particular line, and A, B, C are normal to this plane. So this is 90 degree. That means dot product between ABC and A1, B1, C1 is 0. Dot product is 0 because they are perpendicular. Okay. Basically, this line is parallel to the plane. Clearly, the line is lying on the plane means what? Line is aligned with the plane, parallel to the plane. So, line and plane are parallel. That means dot product is 0. So, two conditions. Yes, you have to remember the two conditions. So, let me summarize. If a line has to lie in a plane, the point on the line has to lie on the plane, and the dot product between line and plane should be 0. Okay. Let me just do it with the help of exam. Do it with the help of example. Yeah. So line lies in the plane. What does that mean? 3, -2 and -4 will be lying on this. So 3x, 3l. Okay. -2m, and we have +4 is equals to 9. So 3l minus 2m is equals to 5. Okay, and we have, okay, one more thing. Now dot product is 0. So 2l minus m, and we have -3 is equals to 0. So 2l minus m is equals to 3. So if you solve these two quantities, what you will get is relation between L and M. Right? So let me just show you the proper solution. So for a line has to lie in the plane, the point lies on the plane. So point is what? 3, -2 and -4. If I satisfy, I'm going to get this. And the dot product will be equals to 0. If you solve these two quantities, what do you get? L is equals to 1 and -1. So 1 square. So 2 is the correct answer. 2 is the correct answer. Option B. 2, 2, 2, 2, 2. All right. Now, intersection point of a line and a plane, very easy. Intersection point of a line and a plane, very easy. I'll be telling you with the help of the example only. So, over here, the equation of line passing through the point of intersection of this line and this plane. So, actually, I need 2, 2, 1. Yeah, 2, 2, 1. So, this is 2, this is 2, this is 1. Equation of line passing through the point of intersection. Let us calculate point of intersection. So over here, point of intersection will be what? X is equals to 2 lambda plus 4, y is equals to 2 lambda plus 5, z is equals to lambda plus 3. And you just assume a point on this line and satisfy in the plane, and you are done. So just satisfy in this plane 2 lambda plus 4 plus 2 lambda plus 5 plus lambda plus 3 is equals to 2. So 4, 5, 5 lambda, 5 और 3 8, 8 और 4 12, 12 तो minus. So lambda is actually coming out as, let us do the calculation. Yes, so lambda is -2. Ten. Yes. So lambda is coming out as -2. The moment you find lambda, you put the lambda over here. So -2. So ये 0 हो गया. -2 ये 1 हो गया, -2 ये 1 हो गया. 0, 1, 1. So any line which passes through this particular line point will be the option. Now we need to check. 0, 1, 1. Is it satisfying? First thing. So the moment I put 0 over here, so -4. And then over here, -4. And then over here, if I put 1, what do I get? +4. So option A is not right. If I put 0 over here, I'm going to get -1. If I put 1 over here, -1. And what is this? If I put 1 over here, I'm going to get no. It is also incorrect. If I put 0 over here, 1. And then 1 over here, 1. And then 1 over here, no. So D is correct. Yeah, 0 if I put -1. 1 I put -1. And 1 if I put -1. Yes, option D clearly is satisfying. Rest all the options are not satisfying. है ना? Not satisfying. So clearly, which option is correct? On the line, this last line. Last line is absolutely right. We need to check. Okay. All right. Okay. Now angle between two planes is pretty straightforward. Just like, so you are given with two planes, right? So cos theta. So cos theta will be a1, a2, b1, b2, c1, c2 upon square root of a square plus b square plus c square. Same cos theta. Perpendicular if the dot product is 0. So this is the simple thing, because plane, no cross connection. In line and plane, when they are parallel, then dot product is 0. In plane and plane, when they are perpendicular, so this is actually normal, then dot product is 0. And parallel if the ratios are same, and in that the things are reverse. Okay. All right. Now distance between parallel planes. Distance between parallel planes. So when, again, similar, like just like distance between two parallel lines, right? So you have first parallel plane and second plane parallel. Understand and realize that both planes are parallel if and only if these two portions are same. That means coefficient of x, y and z are same. Then we will actually say ki okay, exactly like lines. Ki yes, these two are parallel. Then we can apply the formula. If these two are not same, so you have to make it same. Then only you can apply the formula. Okay. So the formula is d1 minus d2 whole upon. So the formula is d2 minus d1 or d1 minus d2, because anyway modulus is there, whole upon square root a square plus b square plus c square. Okay. All right. Just like lines. Yes. d2 minus d1 or d1 minus d2. Okay. All right. Just ignore this. This is the proof part, which we don't want to get into it. It is not important for advanced as well. Okay. Now we have another topic, which is family of planes. And after family of planes, we have non-symmetrical form. And after that, we are having calculus ka wo mean value theorems. Okay. All right. So it will take us another maybe half an hour, 30-35 minutes. Okay. All right. Family of planes. Very easy. Family of planes is very small topic. It looks like family of planes, but it is not that difficult. So basically, family of planes means that there is a plane which passes through the intersection of two given planes, right? So over here, can you see this is plane number 1 and plane number 2? And intersection of plane 1 and plane 2 is giving me a line. And through this line, infinite planes can pass, right? Through this line of intersection, how many planes can pass? Infinite planes. So we need to write that equation of a plane of those infinite planes which passes through the line of intersection of P1 and P2. So one method is you just you have two planes, you just solve those two planes and you just find that line, and then you have that line. So passing through that line, you can write the plane, but that is a very big process. Actually, we have a very simple thing over here. So equation of plane passing through so this, can you see? Yeah. So this is the required plane which is passing through line of intersection of plane 1 and plane 2. And that equation, this plane, let's say this is P. This P plane is nothing but P1 plus lambda P2 is equals to 0. The moment you start changing the value of lambda, you can get those multiple infinite planes, the position of different planes, because this P can rotate and it will have different positions. Okay. So P1 plus lambda P2 is equals to 0. Let us say this is plane 1 equation you can see on your screen. Plane 2 equation also you can see on your screen. Plane 1 equation you can see on your screen. Plane 2 equation you can see on your screen. Now you just have to put the value of P1 over here. So this is your P1 plus lambda times P2 is equals to 0. Okay. All right. Now let us understand with the help of a question. If the equation of plane passing through line of intersection of this and this and the point, okay, then we need to figure out the equation of required plane, and hence 2a plus b minus plus c minus 7. So very easy. First of all, equation of plane passing through line of intersection of P1 and P2 will be what? Let us write. So this is going to be P1. This is your P1, right? Plus lambda times P2. And now, once I get the value of lambda, then I will reach to this particular plane. How to get the value of lambda? By putting this point in the plane. Because this is my required plane which is passing through minus 2, 1, 3. So why not just put this value minus 2, 1, 3 in this plane? So the moment I put minus 1, 2 and 3, I will get my answer. Okay, so put x is equals to minus 1 in this. So this is minus 2. Then we are having minus 7. And then 4 3s are 12 minus 3. Plus lambda times minus 6. Then we have minus 5 plus 12 plus 11 is equals to 0. 12 में से 3 गया 9. 9 minus 0. तो lambda क्या आ रहा है देखो अगर ध्यान से. So if we satisfy this, lambda actually is coming out as 1 by 6. Yeah, it is not coming 0. Lambda is 1 by 6. Okay. The moment you put, directly you put it over here. So lambda directly will be 1 by 6. And once the value of lambda is 1 by 6, what you can do is, you can just plug in the value in this. Lambda is 1 by 6. So this is the required plane. है ना? You put the value of lambda over here, 1 by 6. And you solve it so that you get either this or here. So finally you are going to get what? This. This is the final equation of the plane, right? 15 minus 47, 28. So A is 15. 15 is so 30 minus 47 plus 28 minus 7. So this is going to be 58 minus 47 minus 7. So 57 और 7 14. 4. 4 is the right answer. 4. Okay. All right. So this is all about family of planes. So in family of planes, what kind of questions you will get? That, okay, there is a plane which passes through line of intersection of plane 1 and plane 2. And one information they will give to calculate the value of lambda. Once you are done with the value of lambda, then you have that plane. You can do whatever you want to do with that plane. Okay. All right. Now, non-symmetrical form of a line. Non-symmetrical form. So, basically, okay. So, basically, whenever they give you two planes, P1 and P2, there is a so whenever they give you two planes which are not parallel, so using these two planes you can generate a line. Yes or no? We just saw it. Two planes, two non-parallel planes, the intersection was a line. So there should be a way to calculate that equation of that line. Yes or no? The mathematical equation of that line, how to calculate? Okay. So can you see that there are two planes over here, and two planes are having line of intersection. So we are interested in line of intersection of these two planes. How to calculate? So there is step-by-step procedure over here. So first thing, now to calculate the equation of a 3D line, what do you want? Tell me in the chat box. Think objectively. What I want. First thing is, ma'am, we want direction, cosines or ratio of that line. That is the first thing. Second thing is, anyone, if someone can tell me the point on that line, then we will be able to write that equation of that line. Only two things. Okay, all right. So yes, suppose now I have a laptop. Okay. So now, yes. Let me just open it. Okay, so this is my laptop. This is my laptop. Okay. So this is your plane number 1. Understand, this is your plane number 1. And this is your plane number 2. Plane number 1, plane number 2. Okay, all right. Now plane number 1 will have its direction, will have its normal. So the normal will be perpendicular to plane number 1 and normal of this will be perpendicular to this. Agree or not? Yes. And this is your line of intersection, by the way. This is plane number 1, this is plane number 2, and this is line of intersection which we are looking for. And we are looking for this direction also. So if I take cross product of normal vectors of two planes, what do I get? So that means I need to take, so this is the direction towards this, okay, and upwards this. So if I take cross product of this, what do I get? A cross B. If I take cross product, what do I get? I get this line direction only. Okay, let me just tell you with the help of this diagram as well. Yes. So suppose we are having this plane whose normal vector is this. Okay. This is the normal vector and this is the normal vector. So suppose I take cross product of those normal vector, what do I get? So this cross this will actually align with this particular thing. Cross product will be parallel to intersection line. Yes. So the whole thing, even if you are not understanding the visualization, you have to remember this. Okay. That okay, whenever you are given with two planes and you are looking for line of intersection, you have to figure out cross product of A1, A1, B1, C1, A2, B2, C2 to get direction ratio of that line. Yes. Okay. Right. So कैसे करेंगे? To convert, step 1, get direction ratios. How to get direction ratios? By taking cross product. Step number 1, to get direction ratio, you have to take cross product of A1, B1, C1, A2, B2, C2. Is that clear? Yes or no in the chat box? Okay, that is first thing. So now from this, you can easily get direction ratio. Now you want a point. Step number 2. Step number 2, how to calculate point on that line? To calculate point on the line, what you need to do is you need to put x equals to 0. If you put x equals to 0 in both the equations, what do you get? Is equation in y and z only. Two equations in y and z, which you can solve and you get y comma z. So x was 0, y and z you have obtained and now you are done, right? So take a point on yz plane, that is x equals to 0. And you just solve it. So if this is 0, so only y and z, two equations, two unknown. So you can solve for z. Okay. All right. So now let us do this with the help of example. Okay. So let us reduce in the symmetrical form. First of all, 4, 4 minus 5, 8, 12 minus 13. Let us take the, let us take direction ratio. Can you see? 4, 4 minus 5, 8, 12 minus 13. See, the moment you take cross product, you will get what? Direction ratio of that line. So that means your line will be x minus something upon 8. And this will be 12. This will be 16. Or rather, what you can write is 4 2s are 8. Rather than 8, 12 and 16, you can just write 4, 6 and 8. Or 2, 3 and 4. 2, 3 and 4 are the direction ratios. Right? 2, 3 and 4. Reduced form. And now the moment you put x equals to 0, what do you get? So x minus 0. The moment you put x equals to 0, 4y minus 5z is equals to 12. 12y minus 13z is equals to 32. You solve these two, you get the value of y and z. And once you are done with that, the value of y and z, you can just go ahead and put the value. So 2, 3, 4 are the direction ratios. And in this case, you can substitute z is 0. You can substitute z 0 or you can substitute y 0. So let us substitute z is equals to 0. So that will be actually easy. So x plus y is equals to 3 and 2x plus 3y is equals to 8. If you solve it, you are going to get 1, 2 and 0. So 1, 2 and 0. So over here, let us write it 1. This is how you calculate the equation of that line. Okay, all right. Okay, is that clear? Now one thing, let me be very clear that they will not actually tell you. So this is symmetric form. Actually, two planes, when two planes are written, that means a line is written. When two non-parallel planes are written, so reduce the equation of the line. If they write, there are some students who gets panic, ma'am, reduce the equation of the line. Where is the line? This is plane only. So that's why, that's when I come and explain, actually reduce the equation of line formed by these two planes. That's what they are trying to say. So this actually is a symmetric form of that line, and the two planes is nothing but non-symmetric form of that line. I hope you understand this. Yes? Okay. And now we are having Rolle's theorem. Let us understand Rolle's theorem. Let us take 2-minute water break and then let us restart with the calculus part, Rolle's, Lagrange's. All right? Okay. 2-minute break. Let us come back. Nenu Vachan. Okay. Nenu Vachan in 2 minutes. Nenu Vachas Thanu. I will come. Oh. Nenu Vachas Thanu. I have never thought in my life that I will be interested in learning Telugu, or I will learn Telugu. But now it seems that Telugu is so much fun. Nenu Vachas Thanu. I automatically feel that achievement. You guys sometimes feel sometimes you solve some difficult mathematics problem. What is that feeling? That feeling is actually, oh, some achievement, like I have done it, I have did it. Like that also, like that only I feel. Okay, Nenu Vachas Thanu, I will come. So I have that feeling that, okay, some achievement I'm getting. I have spoken something in Telugu. Okay, chalo. Rolle's theorem, Rolle's theorem, Rolle's theorem. Actually, Rolle's theorem, studying Rolle's theorem is very easy. And application is also easy. But there are some instances, especially for JEE Advanced, that we will do in separate sessions. We'll launch a separate series for problem solving, wherein we will be actually dealing with Rolle's theorem applications, difficult applications. You actually won't be able to think ki okay, Rolle's theorem can be applicable here as well, kya? Like that. You will be actually, troubled that Rolle's theorem can be applicable in this manner as well, kya? Okay. So Rolle's theorem, very easy, very, very easy. That, yes. Fx is okay. So to apply Rolle's theorem in any function, two basic conditions should be there. That fx should be continuous in closed interval and differentiable. Sorry, this is incorrect. Differentiable in open interval. So it should be continuous in open interval, differentiable in continuous in closed interval, differentiable in open interval, and also the value at b and a should be equal. Right? If this is the case, then Rolle's says very important and interesting thing that okay, so if it is continuous, it will not break. If it is differentiable, it will not have a sharp corner. What does that mean? So the graph of this function will behave like this, just like this, or like this, or like this. Like this only. Are you getting my point? So basically, either it will go straight line, or it will just, it will have one single turn, or it will have multiple turns. Okay, but what fixed thing, definite thing, what we can tell definitely. So definitely, minimum number of time it will take one turn. Either it will be straight line, or if the graph want to take turn, minimum the one turn will be happening over here. Multiple turn can be happen, but that is not sure. What is sure thing? Either it is a straight line. If it is not, then it will definitely take one turn. One turn means that one horizontal tangent between A and B is possible. That means between A and B, one horizontal tangent is possible. That means between A and B, at least one time derivative will be 0. So that means there exists at least one value between A and B, and on that value the derivative will be 0. The derivative will be 0. Are you getting my point? Yes. So this is what Rolle's has said. This is what has Rolle's told you. Okay. I will give you one homework question on Rolle's theorem now. Okay, this question we will be taking in the series as well, the upcoming series as well. That if a function is a twice differentiable function satisfying f of 1 is 1, f of 2 is 4, f of 3 is 9. Okay, f of 1 is 1, f of 2 is 4, f of 3 is 9. Then which of the following is correct? So this question we'll be taking, but this right now it is a homework question for you. Can I give you this as a homework question? Will you be able to try it out? Yes. Okay. Okay, hint. Okay, chalo. So the question was f of 1 was 1. F of 2 was 4. F of 3 was 9. So the hint is actually that it seems, it feels. See, the question was f of 1 is equals to 1, f of 2 is equals to 4, f of 3 is equals to 9. What does it mean? What does it mean? That it feels that f of x is equals to x square. Don't you think? Don't you think? But actually it's not the case. You guys are delulu. It's not the case. But you guys are thinking in the right direction. What is the case? So basically, f of x minus x square is becoming 0 at 3 points. So this is a new function g of x. This is let us take a new function, right? This is actually correct thinking, but partially correct, partially wrong. You cannot equate it because only 3 values it is satisfying. You cannot generalize it. Okay. what you can do is you can take this function and what you can say is, okay, gx is becoming 0 at 3 points, which is x equals to 1, 2 and 3. So basically gx is having 3 roots. Gx is having how many roots? 3 roots. Okay. Gx is having 3 roots. So this is your hint. But trust me, this concept is very important. So I'm going to very much take it in advanced problem solving session. But I want you all to think about it and just stay in this. Because JEE Advanced is not like I give you a question, you will solve it. You have to do a lot of thinking. So I just want you to think over it. And we will definitely do it in the upcoming sessions like calculus. The very first session is going to be, I guess, calculus only or matrices and determinants, either of these two. But the first 2 sessions would be this, okay? Now, Lagrange's mean value theorem is exactly extension. You know what? Lagrange's always do like this. Lagrange is like this. Rolls has done some original work, okay? And Lagrange's just do this. I can copy, but smartly. So Lagrange's has copied this, just like in vectors as well. In vectors, it has given Lagrange's Lagrange's identity, wherein a relation between dot and cross product is there. Same thing, nothing original. So Lagrange's is like, okay, Rolls, you have done some amazing job. Let me just copy it with a little bit of twist. So Lagrange's says same thing. That function should be continuous in closed interval. All right. And it is differentiable in the open interval. Okay. I like Lagrange's. The way he copies smartly. Okay. Differentiable in the open interval. But in this case, in Rolle's theorem, f of a and f of b were equal. But in this case, it is not necessarily to be equal. Right? So let me just plot the graph. In this case, they are not equal. So f of a, this is f of a. And this is f of b. This is f of b. Right? Again, and now the function is continuous. So it cannot break. It is differentiable. It cannot have sharp corners. So what it can have is a straight line. And if it is not a straight line, then again it will look like this. Minimum this. Okay. Or it can go like this as well. Turns, multiple turns, but at least it will at least have minimum. It will have certainly, right? Possibility could be anything, but certainly it will have one single turn if it is not straight line. Right? So over here, if I draw a chord joining this point A and B. So this is point, this is your B. This is this. Okay. If I join these two points, right? And parallel to this chord or secant, whatever you want to call it, parallel to this line, if I want to draw a tangent on this curve, it will look like this. So it says same thing. Lagrange's say same thing. It says that, okay, so parallel to this chord, we can draw a tangent. That means slope of a tangent will be equal to slope of this chord, right? And this will happen between A and B. So there exists a point C at which slope of the tangent will be equal to slope of the chord. So f dash C is slope of tangent. This is your slope of tangent at point C. Slope of tangent. This is nothing but dy by dx only at x equals to C. So this is the slope of tangent. That will be equal to slope of chord. Now how to calculate slope of chord? y2 minus y1 upon x2 minus x1. So that is fb minus fa upon b minus a. So fb upon fa, y2 minus y1 upon x2 minus x1. And actually, if you understand, same thing Rolle's theorem said. So in case, Rolle's theorem basically is a special case of Lagrange's. It is different. So one student was saying special case of it. No. Rolle's theorem is special case of it. It actually, Lagrange's had generalized it. Because in Rolle's theorem, what happens? F of B and F of A both are equal. If both are equal, then F dash C is 0. So this actually Lagrange's explained Rolle's theorem as well. It gave something which is generalized version. Okay, but yeah. But I am thinking that I don't know who copies whom. I was in that mindset that okay, because Lagrange's gave that Lagrange's identity which was not original between dot and cross product, and because of this LMVT I thought ki okay, Rolle's gave, because we study Rolle's first and then Lagrange's. So I thought okay, I always used to think okay, Rolle's gave it first and then Lagrange's copy. But then no. हो सकता है, it may be possible that Lagrange's gave it first and then Rolle's was like let me just come and copy, but smartly. Chalo, let me figure it out and tell you in the next session of JEE Advanced that who copies whom, and you also can figure it out, and it is interesting, right? Rather than scrolling reels and shorts, you can just figure it out. First, who gave Rolle's gave first, or Lagrange's? Like Einstein and Newton, that's what you're saying. No, there was a war between not Einstein and Newton. It was Leibniz and Newton. So there was a war between Leibniz and Newton, a very big controversial fight between Leibniz and Newton, which was discussed in court as well, wherein Newton was in the picture ki okay, I am father of calculus, I have written the whole calculus, the idea of the calculus, and Leibniz was like, hey, hello, I was already writing the calculus. But then basically Newton did a case on Leibniz of copying his stuff, his calculus stuff. Okay, so there is a very big, interesting story between Newton and Leibniz. I to enjoy that story. Okay, all right. So this is all about additional topics. So this is LMVT theorem. I guess we are done with it. We will not solve problems on LMVT right now because problem solving sessions will be there. Otherwise, the session is going to be lengthier, right? So yes, I guess we are done with today's session. And this is me, Namrata, signing off. I'll see you all super soon. And please do not forget that tomorrow we have an event at 12. Tomorrow, yes. 30 is tomorrow, no? Yes. Sorry, 30 is today. So 1st May, 12 p.m. Tomorrow we are having an event, VEDANTU 12 p.m. and the link is given in the description box. The event is scheduled from so many days. So please be there. And yes, you are going to have so much fun and so many solutions to your problem. Okay. All right. Yes. Yeah, NK, you are absolutely right. And then after that fight, everybody agreed that yes, Newton is right and Leibniz didn't get that credit. But after Leibniz, after this whole thing that Leibniz did not get that credit and all, Leibniz started falling ill and he actually died. Leibniz died. After the death of Leibniz, everybody started feeling like, okay, the work done by Newton is a little bit different than work done by Leibniz. Okay, so the perspective of Newton's of calculus was related to dy by dx, and that of Leibniz was f dash x, f dash y, right? So yeah, there is a Newton-Leibniz theorem is also there. Yes, definitely. So yeah, so there were two perspectives. See, dy by dx. Sometimes we write dy by dx, sometimes we write f dash c. So basically out of Leibniz and Newton, one was inclined with f dash x approach and one was inclined with dy by dx approach. Okay, so both were actually doing their own stuff. Both have given so much of calculus stuff individually, but then they fought, and you know the controversy. Okay, you can just go ahead and Google as well, or if you want, I can make a video of that once your advanced examination is done, of course. Yes, so I'll meet you super soon. This is me, Namrata, signing off. Bye bye. See you tomorrow 12